Today in your table of contents, we need to add inverse functions. There we go, now I spelled it right. And then you can add whatever page that's on. Oops. So we've talked a little bit about inverses before, and now we're going to take a look at what these inverse functions are. But first, we're going to take a look at with some coordinates. So let's say we have a function, and I'm going to make just an XY table. And let's say it was 2, 3, 8, 5, -2, 7. The inverse, which inverse is denoted with a power to the -1 sign, the inverse, those x, y inverses, you change the x and y. So instead of 2, 3, it becomes 3, 2, 5, 8, 7, -2. So let's take a look. We're going to take a look at a parabola here. And I'm going to graph just a basic x squared parabola. So 2, 4. So here's our parabola. You're going to pretend that it's going through these coordinates here. Sorry about that. Okay, so if I was to make an XY table, we have 0, 0, -1, 1, 1, 1, 2, 4, and -2, 4. Because again, it's just x squared. So our inverse one, so this is f of x. And again, I'm going to use this as our inverse. So we'd still have 0, 0. So that's still there. We'd have 1, -1. So 1, -1. 1, 1 is still 1, 1 when we switch it. 4, 2. 1, 2, 3, 4, 1, 2. And then we'd have, oh, that was a -2. So 4, -2. So there's a graph of our inverse. And what this graph is it's actually, some of you might see it right now, it's a reflection over the line y equals x. So an inverse, a graphical look at it is it's reflecting it over the line y equals x. If you're thinking coordinates, we're just switching the x, y. So now we're going to take a look at how do we find the equations of some of these inverses. So our goal here is we're going to be asked to find the inverse. And this is pretty easy. It's just a lot of algebra stuff. So let's say we have f of x equals 2/3 x plus 5. And our goal is to find the inverse. The first thing we do is switch the x and y. So this is really 2/3 y plus 5. And instead of like a y equals, since f of x is really just y, we say x equals that. And then the last thing we have to do is solve for y. So -5 minus 5. So we have x minus 5 equals 2/3 y. And then to get rid of the times 2/3, we can multiply by the reciprocal, times 3/2. So on this side, we just have our y. And then if we distribute, we have 3/2x. And if we multiply it in, minus 15/2. And so a lot of times you'll see it though, your last thing you'll see it is written with the inverse notation. So you'll see it with that inverse notation. So again, a lot of this is algebra. So let's take a look at another one if we're asked to find the inverse. We're just going to look at quite a few. If I had y equals 4 times the cubed root of x. So again, I don't have it as f of x, I have it as y, but we're going to start the same way. Just switch to your y and x. It doesn't matter if it says f of x or y, the same thing here. So we have x equals 4, the cubed root of y. So it's a little bit messier, but we still want to solve for y. So let's divide by 4. So we have x over 4 equals the cubed root of y. But then we got to get rid of that cubed root. So to get rid of that cubed root, we do to the power of 3. So to the power of 3, and this whole thing to the power of 3. So over here now we just have y. And if we distribute that, we'd have x cubed, and then you cube the bottom as well, over 64. And again, the final way you'll want to write it is with that inverse notation. So today is actually just a big review of some of those algebra skills. So let's take a look at another one here. Let's say we had f of x equals 5x to the 3/4. So again, our first step, change the x and y. So x equals 5y to the 3/4. So to get the y by itself, we divide by 5 first. So we have y to the 3/4. And then to get rid of our exponent, we raise it to the reciprocal power. And so we have x over 5 to the 4/3 equals y. And again, you could distribute to the top and the bottom. So you could distribute that and say this is x to the 4/3 and 5 to the 4/3 as well equals, and then we'll use our inverse notation. So now we're going to take a look at a couple that are a little trickier because they involve fractions. So it's just more challenging on the algebra front. So let's say we have y equals 3 over 5x. So we're dealing with fractions, but the first step is always the same. X equals 3 over 5y. So the tricky part is getting used to this solving for y when it's in the denominator. So multiply by the denominator times 5y times 5y. You might be saying, well, we're getting y's and x's on the same side, but that's okay. So we have 5yx. But now to get the y by itself, we have to divide by the 5x. So we have y equals 3 divided by 5x. And that looks, let's check that. That's verse is the exact same. And that threw me off for a little bit. So then I went to Desmos here and I graphed it. So let me bring this here because I was like, wait a second. What's going on? So let's see if you can see this screen here. And I graphed it and then I was like, if I was to draw the line y equals x, it really is just a reflection over that line because the inverse, x equals 3 divided by 5y, it's that exact same graph. So sometimes your inverse might be the same as the regular function. Okay, so we're going to take a look at a couple more with fractions because that is not always the case. So the next one we're going to take a look at is y equals 2x over 6. So our first step, change the x and y. Okay, so solve for y times 6 times 6. So we have 6x equals 2y. Divide by 2, divide by 2. So we have 3x equals y. So 3x is equal to our inverse there. The next one, 2 more with fractions. We're going to kind of build these up to get to the last one is probably the trickiest one there, algebraic wise. So let's say we have y equals 5 over x minus 6. So our first step, change the x and y. X equals 5 over y minus 6. So we don't want y in the denominator, so we'll multiply by y minus 6. And since there's the two terms, I'm going to put that in parentheses. So now we just have 5. And then if we distribute, we have xy minus 6x. So it looks like it got more complicated here, but now it's really easy to solve for y. Let's add 6x. So we have xy equals 5 plus 6x, and then let's divide by x. And I'm going to go right to that inverse since y is by itself. So our inverse is 5 plus 6x over x. And the very last one that we're going to look at, y equals 2x minus 3 divided by 5x plus 1. So by now that first step should be nice and easy. We change the x and y. So x equals 2y minus 3 divided by 5y plus 1. And you'll notice now we have y's on the top and bottom, but start the same way. Let's multiply by our denominator. So on this side, now we have 2y minus 3. If we distribute, we got 5xy plus x. So there's x's and y's everywhere. So our first thing we want to do is let's get the y's on the same side. So minus 2y. So now we have 5xy plus x minus 2y equals negative 3. And now we want to get the y's by itself. So minus x. So now we have 5xy minus 2y equals negative 3 minus x. And so this last step then, it's one that we haven't done very often. When on the left side, y's are on one side, we're going to factor out that y. So I'm going to pull a y out of that first term. So all that's left is the 5x. Pull a y out of the second term. So all that's left is the 2 equals negative 3 minus x. And now to get y by itself, we just have to divide by 5x minus 2. So y equals negative 3 minus x. Oops, didn't mean to put that box there. So your assignment for today, there are 3 problems that I want you to find the inverse of. So your assignment that I want you to come tomorrow with these 3 done, and you can add them right to your notebook. So all of these you're going to find the inverse of. So the first one is y equals 3x minus 2. I take that back. You're going to do 4. The second one is y equals 1/2 x plus 6. The third one, and I'm going to put some f of x in there, f of x equals 3x to the 2/3. And then the fourth one, f of x equals 2x plus 1 over x minus 6. So those 4, you need to come tomorrow ready to share your answers.